greenhouse gases on Earth and on other planets, it warms the surface of the planet by limiting the amount of heat that's able to escape from the planet. The surface of the Earth is heated by the sun, by incoming shortwave radiation that heats the surface of the Earth, and then just as a light bulb emits heat, the Earth is actually emitting heat back out to space, and what greenhouse gases do is they trap a proportion of that heat and re-radiate it back to the Earth's surface. The concentration of greenhouse gases in the atmosphere has been increasing dramatically for the last several decades, and is continuing to do so with increasing fossil fuel use. And until there's some way to, or some alternative energy source, is going to continue to go up. And what's interesting is that when you look at the range of modern carbon dioxide levels that exist in the atmosphere today, when we look at this longer perspective, going back maybe 1 million years, the CO2 range is, let's say, here between cold and warm periods, and this is time. The carbon dioxide level today is very high. It's much, much higher than it's ever been in the past. And so the future trajectory is just pushing us outside of an envelope of climate stability that we know from the more distant past. The concentration that we're at today is much, much greater than it's been, we now think, for the last 1 million years, and perhaps even for the last 25 million years. We know this from the concentration of greenhouse gases that are trapped in ice bubbles that are preserved in glaciers that were drilled in Antarctica. And so we have these records of climate change that's preserved in the ice, but we also have this record of greenhouse gases concentrations that are preserved in the ice. For the last 900,000 years, it's been this very, very close relationship between warmer and colder climates and the concentration of greenhouse gases, such that colder climates have always been associated with lower carbon dioxide concentrations. And importantly for us today, warmer climates are always associated with higher concentrations of greenhouse gases. The amount of warming that we've seen so far on the planet is only on the order of about 0.8 of a degree. And what we're looking in the future from climate model simulations is something in the order of 3 to 5 degrees centigrade.
Models are the best guess that climatologists have for how the processes and interactions of the climate fit together, how changes in the ocean affect changes in the atmosphere, which affect changes in the radiation budget, which affect changes in the winds, which affect the climate that you and I live with. These models are the laboratories that climate scientists use to examine the different processes and interactions in the climate system. The results of the models are extremely robust. Increasing emissions will lead to increasing concentrations of carbon dioxide and other greenhouse gases in the atmosphere, and that will lead to a significant degree of warming that is perhaps unprecedented over the last 2,000 years and maybe even longer. This isn't to say that these models are perfect. On the global and regional scale, at the continent-wide scale, they do quite well. But at the local scale, the scale of New York City or the scale of Florida, there are a lot of small-scale interactions that aren't very well captured in these models. And so we still have a great deal of uncertainty as to how these big regional patterns are going to play out at the local level. And that's a topic of great research at the moment, and that's something that we continue to work on.
One of the best ways we have to understand the impacts of climate change over the long term is to look at the impacts of climate now. And in the developing world, some of those impacts are very challenging for the countries involved. You have outbreaks of infectious disease like malaria, you have famines, you have disasters, and if climate is causing those kinds of problems currently, then when climate changes and the situation becomes even more unfamiliar to people and the economy, we'll expect to see potentially even worse impacts. The developing world and the world in general have a lot of challenges before them. I think it is starting to become clear to people in the developed world that their success depends on everybody's success, that we're all in this together. And I think global climate change really underscores the fact that it's one Earth and we all have to live on it.
The challenge to the engineer in the end is to stop carbon dioxide emissions to the atmosphere while at the same time providing energy. We don't really have to argue whether we have to stop at doubling of carbon dioxide or maybe we are allowed to go to tripling. At the end, we will have to eliminate carbon dioxide emissions to hold whatever level we have reached. The three options, which each one by itself could provide enough energy for a world population who has reached a high standard of living, would be solar energy, nuclear energy, and fossil fuels. Fossil fuels, we know there are plenty thereof, and the challenge is to figure out how to deal with the carbon dioxide. Nuclear energy needs to get cheaper, needs to resolve the proliferation issues, the waste problem, and has to actually get safer than it is today. That's their challenge. And in the solar energy, the central challenge is how to get the costs down dramatically. This would be particularly important if you use solar energy to make, for example, transportation fuels. In that case, I believe you really have to drive the price down to a penny a kilowatt hour, and right now they are more like 20 to 30. But I think at the end of the day, it's quite likely, if we progress on all of these issues, that we are in a situation where at least one of them will succeed. So in that sense, I'm an optimist that it can be done. The technological hurdles may be steep, but they are not insurmountable.